Hi everyone, today we'll look at Pytorch Datasets and DataLoader classes. These are auxiliary classes that help us load and process data for deep learning applications. So as you know, deep learning models require large amounts of data. They're very data hungry. And for this, we need to usually grab data from a disk, load it up, usually run some processing, and feed it into the model. So for this, we need very efficient algorithms to load and process data in a computationally efficient manner. And for this, the Pytorch framework provides excellent classes and APIs that we can use in order to do this very easily in a seamless manner. And the point of this video is to give you a kind of working model and an overarching way of thinking about this, about what's happening under the hood in the Pytorch Dataset and DataLoader classes. So before we get started, the dataset class is a class that that contains all the data we want for the train set or the evaluation or test set. So it stores all the data within it in an attribute of the class, or it contains methods that fetch the data on the fly and retrieve it when necessary. The DataLoader class has a dataset class. As you can see, the train set is fed into the DataLoader. And what the DataLoader does is it batches all the samples together, shuffles them, and it does this in a very efficient manner using parallel processing, what you can see here as num workers. So the way your project usually is structured is we have a large amount of data, each with their own index. So this can be many different instances, such as images and targets, sequences you want to map to. These can be, for example, only input data samples for something like unsupervised learning. Let's just call it data for now. And all this data is loaded into the dataset class. As we said, it's not always, this can either be as an attribute of the dataset class, or it can be through methods that retrieve data from specific directories from long-term storage and load the data on the fly. And then the dataset class is fed into the DataLoader, which it then uses the dataset class to retrieve the data. So the DataLoader is the one that actually loads the data, and the dataset class has access to the data itself. So for this to work, the dataset class must contain two methods that have to be implemented. These are the len methods, which tell the DataLoader how many samples are contained in the dataset class. This is used to know how many samples are in an epoch and helps the DataLoader structure its batching mechanism. And the second method is the getItem class, which takes in an index as an input and outputs the data sample itself, which we'll see later can have many different formats. But the idea is we ask for a specific index in the data samples, and we get it from the dataset class. So how does the sample retrieval process work? As we said, the DataLoader asks the dataset for a specific index. The dataset goes either to the data loaded within its attributes, or to using the method it calls for a specific index of the data in some kind of long persistent storage, and retrieves a specific index of the data. And this data sample is then returned to the DataLoader. So these data samples, this can be either a tuple of tensors or dict of with several entries, keys and values. It can have many different forms, but the idea is that we ask for a specific index using the getItem method, and we get back a sample of all the data we need for that specific index. And this getItem method is called multiple times by the DataLoader class, and this is how we retrieve data and load it in an efficient manner. However, to speed this up, the DataLoader actually uses many parallel workers. And what these workers do is each one of them calls the getItem method and retrieves their own subset of indices to construct each batch. So this fetching process from the either persistent storage or from the attribute within the dataset class, this is done by the workers, and they all get their own indices, and they retrieve the data and put it into a queue. This is kind of a staging area, which we're going to build the batch from. and the workers access the memory in a parallelized manner, and they put the data samples they get using the getItem method, they put it into this queue. They do this in a parallelized manner. As you can see, it's kind of a mess, which worker gets which index, and the DataLoader class in Pytorch takes care of this mess, locating exactly the indices to each worker and makes sure they don't step on each other's toes. And this is all taken care of under the hood within the DataLoader class. And once we have all the samples in the staging area in this queue, this is going to be a queue of either tuples or dicts, whatever was the output of the getItem method. These are still organized as individual samples, and we want to use them as batches. And this conversion from individual samples into batches is done through what's called the collate function, which is also contained within the DataLoader. And this collate function does exactly that. It takes the individual entries, individual tuples or dicts, and turns it into a single tuple or dict that contains batched tensors. This can also be a batch of strings or a batch of lists or something like that. But the idea of the collate function is that it takes many instances of the tuple or the dicts and puts them into one instance of a batch of tensors or a batch of strings. So that's what the collate function does. It's very flexible. You can use it with many different data types. It's extremely convenient. If you don't think about it, you don't even notice how much work this collate function is doing. So now that we have this batch, this is actually the data that's been loaded and processed. Usually this also goes through some transformations that we can also do either within the dataset class or when we load each individual sample together. But we'll talk about transformations or data augmentations in a future video. For now, let's assume we just have a regular batch. And these are the batches that we get when we call the DataLoader in this format. For batch in train loader, say we have a DataLoader for the training set, or for XY in the train loader. This batch over here, this is either the tuple or the dict of samples that we want to get. So when you use this line for batch and train loader, each iteration of the DataLoader, all this stuff is happening under the hood. So that's kind of a working model of what the Pytorch Dataset and DataLoaders do. This is a very high-level overview. It obviously has much more functionality. I highly recommend looking at the documentation at the Pytorch website. And in the next video, we'll look at a specific example of how to use these Pytorch DataLoader and datasets to make your own custom dataset.